Assalamu alaikum student. In today class, I am starting uh, as level physics first chapter. Okay, on my page or YouTube channel, I will upload these videos. And first, I inshallah complete the as level physics, then chemistry, then biology, then mathematics. Now here I am starting the as level physics first chapter, physical quantities. Inshallah, you will see complete course here on my page on my YouTube channel. Inshallah. A physical quantity is an object property of an object phenomena that can be um, quantified through measurement. Every valid physical quantity must express both a numerical magnitude, size, and the corresponding standard unit. We listen and we read different physical quantities in physics, like we read speed, like now, what is the speed? When we represent the speed, we are using the number and unit, just like 20 kilometer per hour. Now, 20 kilometer per hour mean this physical quantity of speed we are representing here with number and its unit. Now, these two are involved. Here, I'm describing in my notes, so you check. A physical quantity is an objective property of an object, a phenomena. There's a property of phenomena that can be quantified through measurement of every valid physical quantity must express both a numerical magnitude, size, and correspondingly standard unit. Uh, num every physical quantity we represent with uh, number and unit. This is called the magnitude. Magnitude of the physical quantity. Clear, student? This is called magnitude of the physical quantity. So it's mean every physical quantity we represent with magnitude, and this magnitude telling us uh, how much is the quantity, what is the strength of the quantity. Physical quantity is the sum of magnitude and a unit. Okay, here I am representing here magnitude into unit. Both are with each other. That's why we saying both are multiple. Now, base with drive quantity. The quantities type are of the two type. I mention here in my notes, quantities are of the two type. Number one, the base quantity. Base quantity is that quantity which described by itself. Base quantity is that quantity which described by itself. It is not represented by the other. Other quantity is not involved to represent the base quantity. But what are the drive quantity? Drive quantities are those quantities which we cannot represent without the base. Base help to represent the drive. Okay, it's mean physical quantity depend on the two physical quantities are of two types: base quantity, drive quantity. Base quantity of foundational. Here I show in my notes conventional chosen set of the seven independent physical dimensions from all other units and mathematically constructed. Base basically represent itself. These are independent, not dependent on the other. Drive quantities form dynamically via the multiplication, division, algebraic combination of one or more base quantities. Drive we represent with the base quantity. Base quantities are multiplying, dividing, then with the help of these, we represent the drive quantities. Now here are, I show in my notes, we check, there are seven basic quantities. Here you check in my notes. length, which is in meter, base SI unit of the length, meter, symbol M, mass, kilogram, kg, symbol, time, second, S symbol, electrical current, ampere, A symbol. So these are the base, okay? These are not formed with other quantity. These are representing independently by itself. Thermodynamic, Kelvin, by K, amount of substance, mole. These are the some basic quantity. Okay, must remember these are the some basic quantity: length, mass, time, electrical current. These are the four, and two. These are Kelvin and Kelvin unit for temperature, amount of substance, and mole. Light intensity also involved in basic quantities. I didn't show here, but it is also involved light intensity. The unit of the light intensity candela. In our course, we are not using commonly the light intensity. Light intensity, we are using very less. Now, driving the SI base unit for complex quantity. With the help of base quantity, we drive the complex quantity. These are the drive quantity. Just like velocity, we represent with distance and time. Distance is length, time is the time, and both representing base quantity, representing the velocity here. The unit is meter per second. Acceleration, we represent by velocity upon time. Velocity basically drive, and time base. Velocity when we change into basic, convert into meter per second. It's mean velocity is made up by basic, time is basic. Basic are forming the drive. Force, it is the drive quantity. It is formed with mass and acceleration. Mass is kilogram and acceleration meter per second square, both representing the force, mean base quantities, mass, and acceleration also drive. Acceleration also formed with the basic. These all basic forming the drive quantity. Weight also a drive quantity. Force into distance multiple. Force can be represented. Force is also drive, and we can represent it by base quantity. Distance is also a length. It is a base quantity. What done? We can represent these all unit as a joule, and kilogram meter per second also represent by Newton. Now power is also drive. It is formed with work and time. Time is basic. Work we can also change into basic, and it is also drive and formed with. Mean all these quantities are the drive quantities which are formed by the uh, basic quantities which I show in my uh, table which I prepare for the basic quantity. Mostly using normally there are seven basic, but here I should mention here in my notes some basic quantities, six basic quantities. These are very important. These are we are using in different places. Homogeneity of physical equation. What is the homogeneity? An equation is graphically explicitly homogeneity. Equation is explicitly homogeneous, and only if every standard term is separated by a plus, minus, equal sign, share, identical base unit. Checking homogeneity is an essential tool for verifying the structural validity. With the help of homogeneity, we can also check the strength, we check the standard of the quantity. Okay. Just like you check here, I wrote here, for example, while every physical correct equation must be homogeneous. When we represent a unit equation, this equation, uh, every law equation, physical equation, also describing the homogeneity of the quantities, and it is homogeneous. A homogeneous equation is not uh, guaranteed to be physical correct. This is because homogeneous equation can uh, dimension constant, like basically when we are proving the homogeneity of an equation, numbers are also involved. These numbers we ignore. We only discuss the unit. With the help of unit, we can describe the homogeneity of the equation. Just like I'm writing here a distance equation. Okay, distance equation, which is S equal to ut plus half at square. When we are proving the homogeneity of this equation, we're using all unit of both sides. Just like distance is meter and speed is meter per second, time is second. We are using the all unit of both sides and solving it and checking whether the meter is coming or not equally on both sides. Acceleration is meter per second square and second square also time. Now here you divide the second square, second. Now what is left here? Meter plus half meter. When we add, we get 3 by 2 meter. When we are proving the homogeneity, we are not involving the number, okay? Number also involved. This number disturb us. There is not homogeneous this one because number is different. But we are not considering the number. Only we consider the units, base units on both sides. If these are same, it means equation is homogeneous. Here, the both side meter is coming. It means equation is homogeneous. This is the homogeneity. While every here I wrote about that. While every uh, physical correct equation must be homogeneous. Must be homogeneous mean the units are same. Homogeneous equation is not guaranteed to be physically correct. Mean constants are coming. This is signs are coming, constants are coming. These sign and constant not affected on the units. Prefixes and the standard form. The standard form of an efficient numerical notation where physical values formation with a non-zero digit before decimal point multiplied or relevant power, we use mass of Earth just like 6 into 10 power 24. This is the standard, okay? We write in the exponent form. It's like 6 into 10 power form. This is the standard representation of the numerical value of the unit. Only one number involved, and after the one number, there is decimal involved. Others maybe change into 10 power. Unit prefixes are standard alphabetical symbols placed immediately preceding a unit, denote fixed positive or negative power. Powers are maybe positive or negative in this situation. Now, this is the standard form. And what are the prefixes? I'm coming towards the prefixes. Here you check in my notes. What are the prefixes? Just like deci is prefix, it is come as 10 power minus 1 with a uh, unit, kilo 10 power 3, centi 10 power minus 2, mega 10 power 6, and milli 10 power minus 3, giga. These are coming with the units, just like kilometer, which means 10 power 3 meter. Okay. These are the prefixes which are coming with the uh, quantity units. Okay. These are coming. Just like here is, we wrote here because there is a large number of the radius, uh, Earth, mass, there is large number of power, 10 power 24. When just like here is coming 6 into 10 power 6, we represent as a 6 mega. Okay. Now these are the prefixes which are also coming with the units. Now, advanced measurement techniques and instrument, what are experimental instrument architecture? Here I wrote in my notes, length measurement, measuring tape range greater than 1 meter. Measuring tape range is greater than 1 meter. Meter rule range 10 millimeter or 1 meter. It started from 10 millimeter and ended at 1. Resolution of this one. The smallest unit of the meter scale is 1 meter, millimeter. Vernier caliper, 10 millimeter to 150 millimeter. Basically, its range between less value and higher value. Resolution 0.1 millimeter. Mean all these instruments measuring a less quantity accurately, just like tap only measuring 1 meter, meter rule measuring 10 millimeter to 1 meter, and 1 millimeter is approximately less quantity, which is known as the least count. Variable 0.1 millimeter least count. This is the least quantity we can measure with the help of these instruments. Micrometer screw gauge also 25 millimeter range, and it is we measure in decimal after the decimal two-digit reading, just like 0.01. I mean, when we are using this instrument, the we can measure a smallest value from measuring tape to micrometer smaller. Now, mass measurement, top fan electronic balance we use for the measurement of the mass. Spring balance we are used for the measurement of mass and weight. Lever beam balance also used for mass measurements. Internal measurement, simple pendulum, oscillation. Time interval measurement we measure with the pendulum oscillation, and digital analog stopwatches we are using for measurement. Now these are some instrument and some quantities we are measuring. Uh, in and over a study, we are measuring these quantities. Now, length measure and breakdown weight. Meter rule we use smallest division of the meter rule 1 millimeter, 0.1 centimeter. Absolute uncertainty is 0.5. Okay, half of the smallest reading uncertainty present in the meter rule reading 0.1, and half of the 0.1, 0.5 millimeter for a single reading, and 1 millimeter for a double ended length. Okay, 1 millimeter, which is 0.1 centimeter, and 0.1 millimeter when we divide it, it will be 0.5. 1 millimeter in millimeter, it is 0.5. And the single reading plus minus 1 millimeter for a double-ended length we use. These are the some reading belong to the meter rule. Smallest division 1 millimeter, and the absolute uncertainty of the half of the smallest division 1 millimeter 0.5. Primary error, parallax error. No, we comes towards the error. What is the error? Primary error, parallax error, uh, mitigated by the positioning eye directly perpendicular to the scale line, and zero error for physical wear on the rule stick. Basically, the primary errors are the parallax error, zero error. These are the error. These are also present in the instrument, and we measure with the help of instrument. Now, primary causes, miscalibrated instrument, uncorrected zero offset, environmental bias. Uh, Correction method cannot be minimized by averaging, require recalibration, zero adjustment, or subtracting one. How we adjust the primary error? We adjust the zero error firstly, or the parallax error. We see the reading directly perpendicular on the reading, then we can adjust the primary error. What is the random error? Unpredictable, fluctuating variation that cause data point to scatter randomly on the both sides of the true base line. This is the random error. This is near to the when we are taking reading, it is coming near to the actual value. Primary causes: visual parallax variation, sudden ambient temperature shift. All these are involved, due to which there is a random error formed. Correction method can be effectively minimized by taking multiple independent reading. When we are taking multiple reading, then this error can be we minimize, or we can go towards the accuracy. So what is the accuracy and precision framework? Accuracy reflect how close the experimental average single value of the accepted true value. Accuracy is maximized by aggressively hunting down and eliminating systematic error. When we are reducing the error, systematic error, we going towards the accuracy, mean we are calculating here the accurate reading. And what is the precision? reflects how closely a clustered set of the repeated independent measurement agree with each other. Precision is bounded strictly by the finest resolution limit of the chosen apparatus. Now, when we are taking a good instrument, um, we can remove the precisions. Accuracy, which is the total same reading, accurate reading, near rest reading to the accurate precision, it is closely coming to the nearest accurate reading, and we can remove it by finance resolution limit or choosing a apparatus. Advanced uncertainty, we solve this one by the different formulas. Then we get the solution of the answer. Inshallah, in tomorrow class, I will tell you how we solve the uncertainty. Here are some formulas given. With the help of some example, I will tell you how we solve the uncertainty. Okay, study these notes which I show you here in my lecture, and check is there anything which is not clear. Inshallah, in tomorrow class, I will tell you the other remaining topic and the measurement limitation and cathode ray oscilloscope uh, as a dynamic tool, or error accuracy and precision example. I will show you with the help of image, and inshallah I will complete this chapter tomorrow class. Follow my page, subscribe my channel, and get more video written. I have also notes of these. I am online math, physics, chemistry. I have all topic notes of physics, chemistry, biology, which I prepare myself. If you study with me, I will provide you these notes. My academy is Academy of Sciences. This is the global tutoring. You study with me and know about all the things which are in subjects of physics, math, chemistry, biology. Inshallah, I will also starting the group classes, online classes for physics, math, chemistry, biology. Contact me, inshallah, and follow my page. You will get more video related to the O and A level and IB level topics. Okay. First, inshallah, I will complete the AS level physics here, and see my page and follow my page. Inshallah, you get more video. I'm starting here my course of physics, math, chemistry, biology here, totally uploaded here, and you will get total videos. You can also ask if anything is not clear uh, on the comment side. If anything is not clear, I will explain it for you. Allah Hafiz.